Hi, today we're going to talk about how to find compound probability. That means find the probability of multiple events happening. So up here on the screen I have, what is the probability of rolling an even number, so that'd be on a regular six-sided die, and then flipping a heads, so like flip a coin, it's heads or tails. There are multiple ways that we could solve this. One strategy would be making a list. I could roll a 1 and then get heads, that's a possibility, or a 1 and get tails, or a 2 and get heads, or a 2 and get tails, or a 3 and get heads, or a 3 and get tails. I could roll a 4 on my dice and then flip a heads for my coin. I could roll a 4 on my dice and, not flip heads again, but I could get tails on my coin. I'm almost done. I wish I could fit it all down here, but the list is so long. I could get 5 and heads, or 5 and tails, or 6 and heads, or 6 and tails. Okay, then I can find all of the places on my list that has an even number and heads. So that's not even, so it's no good. These are both even, but this is the only one with heads. So here's 1. These are not even. These are both even, but this is the only one with heads. So there's 2. These are not even. These are both even, and this is the only one with heads. So 3. So there's 3 possible times out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 out of 12 possible outcomes are even with heads. I can simplify that to 1/4. So there's a 1/4 possibility of getting an even number and flipping heads. That is one strategy. You could do this with a list, with a table, with a tree diagram, anything like that. But honestly, this can take a long time. Okay, we're lucky that heads had only 2 options. What if I rolled a die, and then rolled another one? Well, then my ones would each have 6 options instead of 2. And then my 2s would have 6 options instead of 2. And my 3s would have 6 options instead of 2. So that list would be huge, or the tree diagram or the table would be really big. So there is another way that we can find the probability without having to make the list. First, let me find the probability of an even number on the die. There are 6 possible numbers on a die. 3 of them are even. So the probability of an even number is 3 out of 6, which is 1/2. Then, so I first found the probability of an even number, which is 1/2. Then I have to find the probability of heads. Well, when I flip a coin, there's only 2 possibilities, and one of them is heads. So it's 1/2. Now I'll tell you right now, yes, these are both 1/2 probabilities. They're not always going to be the same number. That just happens to work for this problem. Now, because you're looking for 2 things that you want, yes, both of these things to be true. You want even number, and yes, you want heads. Then you multiply these together. And that's literally all you do. When you multiply fractions, you multiply straight across. 1 times 1 is 1. 2 times 2 is 4. And there we go. I didn't have to make a big list. This right here is all the work that I had to do. So whenever you're looking for 2 probabilities, and yes, you want them both to happen, you find each probability and multiply them together. That is one type of compound probability where, yes, you want both things to happen. Here is another type of probability where you want one thing or a different thing to happen. Like, hey, I'm happy either way, honestly. It doesn't particularly matter. Notice how this is different from last time. Last time we wanted this and this. So this and this, last time, we multiply. This time is this or this. So let me show you what we're going to do. So the probability of rolling a 5 or a 3. Well, I could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And now I could just count. There's 1, 2, 3, 4, 5, 6 possible outcomes. And 1, 2 of them are a 3 or a 5. So 2 over 6, which simplifies to 1/3. So notice this doesn't say I'm rolling multiple times. I'm going to roll my die. What's the probability I get a 5 or a 3? So here I made a list and I just was able to create that probability, but let me show you another way I could have done it. I know that each number on a die has a probability of 1 over 6. So rolling a 5 has a 1 in 6 chance of being rolled. A 5 has a 1 in 6 chance of being rolled. A 3 also has a 1 in 6 chance of being rolled. Now remember last time I multiplied them together because I wanted both things to happen. Well, this time I'm fine with either of them. I'm happy either way, it doesn't matter. So because it's or, I just add them together. So when I add, I have to have a common denominator. So if I don't have a common denominator, you have to go change it. So you do have a common denominator. So it stays the same. And then you just add straight across. Boom, there you go. And just like before, we can simplify that to 1/3. So these are two different strategies for finding probability when you are find this or that. So just as a refresher, if it's I want two things and this and that, you multiply. If there's two things and you say I want this or that, I'm okay either way, but they don't both have to happen, then you add them together. That's compound probability.